Good morning, students. Today we are going to study about Maxwell's equations. Maxwell, he explained the concept of electromagnetic fields by using a set of four equations. So let us study these one by one. So first equation is del cross E is equal to minus dou B by dou T. That is del cross, it is curl of electric field intensity is equal to minus dou by dou T. That means dou by dou T is the rate of change. Negative means the negative rate of change of the magnetic flux density. So the meaning is the flux, it creates some electric field. So this law is known as Faraday's law. Now the second equation is del cross H is equal to J vector. That is curl of magnetic field intensity is equal to current density. That is the current creates some magnetic field. So this equation is known as Ampere's law. Okay. Now the third equation is del dot D is equal to rho. That is del dot means divergence of electric flux density that is equal to rho. Rho is current density. Sorry, it's charge density. J is current density. Rho is charge density. So the charge, it creates some electric field. So this equation is known as Gauss law. Gauss law of, since we are dealing with only the electric thing, so electric charge creates electric flux, this equation is known as Gauss law of electrostatics. Now the fourth equation is del dot B is equal to 0. That is divergence of magnetic flux density is equal to 0. The meaning is there is actually no magnetic charge exists. Okay, so this equation is known as Gauss law of magnetostatics. Okay, so using these four equations, Maxwell explained the concept of electromagnetic fields. In addition to this, he modified the second law, that is the Ampere's law. Actually, he analyzed this equation, whether this equation satisfies the principle of conservation of charge. Principle of conservation of charge. So in order to analyze this, he used the equation of continuity. The equation of continuity is del dot J is equal to minus dou rho by dou T. So in order to check this equation of continuity in this Ampere's law, first let us take del dot on both the sides. Okay, so let us rewrite the Ampere's law again. That is del cross H is equal to J vector, and in this equation let us apply divergence on both sides. So del dot del cross H is equal to del dot J. Okay, so based upon the equation of continuity, we must get the answer as minus dou rho by dou T. But what happens based upon the vector identity del dot del cross H, del dot, that is divergence of curl of any vector, will be equal to 0. Okay, so this equation does not satisfy the equation of continuity. So Maxwell added an extra term in the same equation. So let us rewrite the equation again. That is del dot del cross H is equal to del dot J. So in this equation he added an extra term as plus dou rho by dou t in order to make this equation satisfy the equation of continuity. Okay, so in this equation, let us apply the rho by using the Maxwell's equation. So we know that the Maxwell's third law, that is del dot D is equal to rho. So instead of rho, we are going to substitute del dot D in this equation. So let us write the equation again. Del dot J plus dou by dou T. Instead of rho, we can write del dot D based upon the third Maxwell's law. Okay, so in the next line we are going to interchange these two. So let us write del dot J is equal to plus del dot dou D by dou T. Okay, so in both the terms we have del dot as common one, so we can keep it outside the bracket and we can write it as del dot J plus dou D by dou T. Okay, so let us write the left hand side also, that is del dot del cross H. So in both the equations we have del dot in common, so we can cancel this and we can write it as del cross H is equal to J plus dou D by dou T. Okay, so this equation is the modified Ampere's equation. So look at the Ampere's old equation. It says del cross H is equal to J, and the modified. So Maxwell modified the Ampere's law and he found this equation, that is del cross H is equal to J plus a new term plus dou D by dou T. Okay, so this equation is known as modified Ampere's law. Okay, or we can say it as Maxwell Ampere's law. Okay, so in this equation J, we already knew it, that is J is current density. More specifically we can say it is conduction current density. Okay, so J is conduction current density and dou D by dou T, the term dou D by dou T as displacement current density. Okay. Now, all the four equations are consistent with the principle of conservation of charge. So, let us rewrite the consistent Maxwell's equation. So, the first equation is del cross E is equal to minus dou B by dou T. The next, del cross H is equal to J plus, let us write the new equation, J plus dou D by dou T. Next, the third equation is del dot D is equal to rho, and the fourth equation is del dot B is equal to 0. Okay, so these four equations are known as Maxwell's equation. Maxwell's equation in point form, because in all the four equations we have del cross, del dot, everything. So this equation is in point form. Okay, so in order to convert this point form equation into integral form, so let us write the heading as integral form of Maxwell's equation. We have a two-step procedure. It is very simple. Suppose if the equation contains del cross term in it, the two-step procedure involves, first we have to take surface integral on both sides. Okay. And the second is apply divergence theorem. Sorry, it's applying Stokes theorem. Okay. So for the first case, we have to apply Stokes theorem. Suppose if the equation contains del dot term in it, okay, then the two-step procedure involves, first we have to take volume integral, okay, then we have to apply divergence theorem, okay. Now let us see it one by one. So first let's take the Faraday's Maxwell's law, okay, that is del cross E is equal to minus dou V by dou T. Since we have uh, del cross in this equation, so we have to apply first surface integral on both sides. So let us apply surface integral on both sides. Surface integral of del cross E dot ds. Okay. On the right hand side also we have to take the surface integral, that is minus dou b by dou t dot ds. Okay. So in this equation, what is the second step? We have to apply Stokes theorem. So we all know what is Stokes theorem. Yes, the Stokes theorem actually converts surface integral into closed line integral, and it removes the del dot term, sorry, del cross term. Okay, so what happens when you apply Stokes theorem in the left hand side? The surface integral becomes line integral. Yes, surface integral becomes line integral, and we can remove this del cross, as we can simply write the E. Okay, in the right hand side we can write the equation as it is, dou b by dou t dot ds. Okay, so this equation is known as first law of Maxwell's equation. Okay, first law of Maxwell's equation. Okay, now let us take the second equation. So this is the first equation. So let us take the second equation. Our second Maxwell's equation is del cross H is equal to J plus dou D by dou T. Okay, so in this equation we have to apply this two-step procedure. First we have to take surface integral. Okay, so let us take surface integral on both sides. Del cross H is H dot ds, and the right hand side also we can take the surface integral of J plus dou D by dou T of ds. Okay, so what is the next step? We have to apply Stokes theorem. What is Stokes theorem? We can change the, okay, we can change the surface integral as line integral, and we can convert curl. Okay, you can remove the curl and it becomes H dot dl. Okay, the right hand side we can write as it is, surface integral of J plus dou D by dou T dot ds. So this becomes the second law of Maxwell's equation. Okay, now let us write the third equation. What is the third equation? Del dot D is equal to rho. So here we have divergence, del dot term. So as per the rule, if del dot divergence term comes, we have to first take volume integral and then have to apply divergence theorem. So let us take the volume integral on both sides. So volume integral of del dot D dot dv, which is equal to volume integral of rho dot dv. So in this, if we apply divergence theorem, similar to the Stokes theorem, divergence theorem converts volume integral into closed surface integral. And similarly, the divergence here is removed. Okay, so we can directly write the d and you can write the surface integral. Okay, it is very simple, and the right hand side we can write the equation as it is. So this becomes the third law of Maxwell's equation. Okay, now let us write the fourth equation. Fourth is del dot b is equal to 0. Okay, similar to the previous case, we can apply a volume integral on both sides. So volume integral of del dot b dot dv is equal to 0. Okay, and here if you apply divergence theorem, what happens? It becomes closed surface integral, and we can remove the divergence term b dot dv, that is equal to 0. Okay, it becomes surface integral, so we can denote it with ds and it will be 0. So this is the fourth equation of Maxwell's equation. Okay, so these are the four equations of Maxwell in integral form. So sometimes we may have to write the above Maxwell's equation only in terms of E and H. So in that case, what we can do is we can use a simple relationship between B and H, that is B can be written as mu H, and similarly D can be written as epsilon E. So with these two relationships, we can rewrite the Maxwell's equation as, so let me erase these equations. Okay. Yes. So if I substitute B is equal to mu H, okay, so what will happen? I'll rewrite del cross E can be written as, so if I substitute mu H here, mu can be taken outside of this differentiation term, so minus mu dou H by dou T. So this is another form of Maxwell's equation. And the second equation, I will take del cross H is equal to J plus, and if I substitute D is equal to epsilon mu, so I can take the epsilon outside of this differentiation, so it will come as epsilon dou E by dou T. Okay, and similarly in the next equation, if I write del dot D is equal to epsilon E, I'll have epsilon E in this instead of this D, and that epsilon, if I bring it to the right side, it will come to the denominator. So I can write it as del dot E is equal to rho by epsilon. Okay, and finally del dot, instead of B, if I substitute mu into H, so mu into H, if add that mu, if I bring it to the right side, it will become 0. So we can write it as del dot H is equal to 0. So these are the four equations only in terms of E and H. Okay. So these are also called as Maxwell's equation. In either way we can write. Okay. For integral form also we can change in the same way. Thank you.